Hello, I'm Garrett Beck, and today I'm presenting three types of DC motors. There are three different types of DC motors: fixed field, series, and shunt motors. These motors are very similar but differ with the magnetic field. To rotate its coil, the fixed field uses permanent magnets. This is evident by the inductance field that is independent from the rest of the system. The series and shunt motors are larger motors where permanent magnets are not realistic. As a result, these motors use an electromagnetic field coil that is dependent with the voltage source. The series motor connects this coil in series, while the shunt motor connects it in parallel. These diagrams are also used to find the transfer function and step response. These transfer functions are in the form required to transfer between the transfer function and the step response. However, this is not the form MATLAB needs in order to compute this data. These equations are the final form I found for the transfer functions that would work with MATLAB. For the sample data, I selected my own points and then tailored them to meet the requirements for the class. As a result, each motor has its own set of data points. Now here's something interesting, especially if you're working on a DC motor. According to this graph, this transfer function will be increasing in a straight line without end. However, as seen in the next slide, if you plug the data into MATLAB's Ciso tool, the graph changes into a steady state. So, why is this transfer function not working properly with the step function, but is working properly with the Ciso tool function? Well, to answer that, an explanation is in order. The source of the issue is with how the transfer function is set up. When solving the transfer function to the time domain, you receive this unique equation. By examining this equation, we can see that as t goes to infinity, EC of t will go to infinity, while e to the negative at goes to 1. One thing to note, although the figure in the previous slide appears as if the function is a straight line, the line does have a curve in it. We just can't see it. So in terms of the step and Ciso tool functions, why do they differ? The answer is that the step function is an open loop while the Ciso tool function is a closed loop. This is why one steady states out while the other goes to infinity. The Ciso tool places the function into a feedback loop function, while the step function only plots the data on the graph as it stands. To recap on what was discussed with DC motors, we covered the different types of motors, the transfer function and step response, and plotting with the step and Ciso tool, and the explanation between open and closed loops. That concludes my presentation. Thank you for your time.